Hello, this is Miss Clausing. So today I'm going to go through, or this video is going to go through the Unit 8 Day 1 notes, which is on arithmetic sequences and series. Okay, so we have two types of sequences and series we talk about this unit. Arithmetic, which I'll talk about in this video, and geometric we'll talk about next class. So let's get started. Sequences. Sequences are just sets of numbers, so a set of numbers that follow a pattern. Okay. Series are just a sum of a sequence, or sum of a set of numbers in a sequence. So sum of a sequence. Okay. So if you were in class, we did this warm-up where you had to go through and find the pattern and find the next number in the pattern. So the first one, it was triangle, square, square, triangle, 3 squares, and then another triangle. So triangle was the next term. The second one, we added 3 each time, and so our next term was 18. When you add the same exact number every time, when your pattern is adding 3, so like in number 2 here, it is called an arithmetic sequence. When you add or subtract the same number every time as your pattern, it is an arithmetic sequence. Okay, I think everyone's pretty familiar with these kind of sequences. Number 3, the pattern was that it was perfect squares. So, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is 25, 6 squared is 36. So 7 squared gave us the next term, which is 49. That's just a sequence. It follows a pattern, but it's not arithmetic and it's not geometric. Okay, it's just a sequence. Number 4, the pattern is you multiply by 2 each time. So when you multiply by 2 each time, the next term would be 32 times 2, which would get me to my 64. When you multiply by or divide by the exact same number every time as your pattern, it's called a geometric sequence. Okay, we'll talk about geometric sequence next class. This video and this last class was arithmetic sequences. We're adding and subtracting by the same number every time. So like in example 2 here in our warm-up. Okay, so let's go back to our notes. So when we identify that something is an arithmetic sequence, there's formulas we can use to both write the rule or write the rule that describes those patterns. And then also we can use that rule to solve for specific terms we're looking for in that sequence. Okay, so if I was looking for like the 82nd term in a sequence that was arithmetic, I could write a rule for that and then quickly find what the 82nd term would be without having to write out every single term 1 through 82. Okay, so the rule, or whatever describes that pattern, is called our explicit formula. So this is the rule for the pattern. Okay, it's just the rule for the pattern, or rule for that sequence. Sorry, I'm actually going to say rule for the sequence. Maybe. Okay, so the rule for an arithmetic sequence, or for a sequence. Okay, rule for a sequence is called an explicit formula. So these A and B here are examples of, under example 1, are examples of a rule for an arithmetic sequence. Now it's asking me to find the first 5 terms. We're going to do this by hand first. So to find my first 5 terms, I'm going to take n is whatever term I'm on, so it'll be a sub 1 for my first term. And I just plug in that 1 wherever I see n in the formula. Okay, and then I want a sub 2 because I want the first 5. So a sub 2 is 4 times 2 plus 5. A sub 3 equals 4 times 3 plus 5. A sub 4 equals 4 times 4 plus 5. And I want the first 5 terms, so a sub 5 equals 4 times 5 plus 5. Okay, so then I just solve all these out. Change color so it's easier to see them. And then if you were to solve this, 4 times 1 plus 5 equals 9. 4 times 2 plus 5 equals 13. Our third term, a sub 3, is 17. Our fourth term is 21. And our fifth term is 25. Okay, so finding the first 5 terms in the sequence, if we wanted to write this how we saw it in our warm-up, our sequence would be 9, 13, 17, 21, and 25. So the first 5 terms in the sequence that is described by the rule here, 4n plus 5, the first 5 terms are 9, 13, 17, 21, and 25. Okay, so that's a sequence of numbers. If I wanted to know the series from term 1 through 5, right? So this is my first term, second term, third term, fourth term, fifth term. A series is just the sum of those numbers. So I just add them up. So 9 plus 13 plus 17 plus 21 is 25. I don't need a plus sign at the end. So the sum of the first 5 terms would give me 85. So this is how we would do it by hand. If it'll let me write it. Alright, so the series is 85. Now the way you would notate this is you would write the sum sign, which is a sigma. And we want to know from our first term through our fifth term. We want to know the sum from our first term through our fifth term. So you write x equals 1, your first term in the bottom. And through the fifth term is what I want to know it through. You could put anything there. I could want to know the sum through the 82nd term. I put in 82 where I see that 5. Okay? And then I put the rule here. The rule was 4n plus 5. Okay? So right above this is where we solved it by hand, but let's do it in our calculator now. So if I go to my calculator, maybe. All right, so I want to get to that sigma. To get there, I go math. We'll write these steps down in a second. And I scroll up, and you can see this little sigma here under 0. So I'm going to push 0. And I literally just fill this in. Now, we used an n, but you can use an x. You can use any variable you want. X is easier to find on the calculator, so I use an x every time. X equals 1. And I want to know from the first to the fifth term, so I put a 5 on top. And I put my rule in the parentheses. Remember, I changed it to an x, so I'm going to put in 4x instead of 4n. And it's plus 4x plus 5. And I push enter. And my calculator will find that sum for me, which equals 85. Okay? So to do this in the calculator, remember you push math. Then you push 0, which has that little sigma. And your calculator basically walks you through it, right? Your calculator says, all right, now what do you want to put into this box? What do you want to put into this box? What do you want to put up above? And then put in your rule. So that's what it looks like in your calculator. You literally just type everything in. Push enter. Okay? So let's just practice this real quick on B here. Practice using our calculator. So we've talked about how to do it by hand. Find a sequence. We've talked about So we've gone from a rule. We started with this rule. We've turned it into a sequence right here. And then we found the series right here. Okay? So we've kind of gone through all the steps that you will need to do. All right, so then here we have our sequence, or our series. Let's just practice doing this in our calculator. Literally, remember, go to your calculator, go to math, go to 0. You can just type 0, you don't have to scroll. X, 1. Even though it gave me K's, I can use X's instead, as long as I'm consistent. So 5, and again, I'm going to change that K to an X, so it'll be 2X instead of 2K, minus 1, and I push enter, equals 25. Okay, so B, when I put it in my calculator, equals 25. All right, so that's about it for there. Okay, so let's talk about what arithmetic means. Remember, arithmetic means you are adding or subtracting by the same number in your sequence, okay? So let's talk about here. Number 1, what's my pattern? My pattern is that I'm minusing 4 each time, okay? So my pattern is that I'm subtracting by 4 every time. It's the same number I'm subtracting by. So this is an arithmetic sequence. Number 3, I got to identify my pattern first. My pattern is I add 1, then I add 2, then I add 3. This is not adding or subtracting by the same exact number every time. So this is not arithmetic, okay? So there's a difference between arithmetic and not. Number 3 is a sequence. It is a pattern, but it is not arithmetic, okay? Okay. So arithmetic sequences, you can use, there are formulas. If you identify that a sequence is arithmetic, you can have formulas that will allow you to write that rule. So on this first page, notice I gave you the rule under A, the example for A, I gave you the rule. But you can also be given a sequence, like here, I'm giving you a sequence and I want you to write the rule. So it says write the rule. So the formula for this is given to you on the SOL, but it's A sub n equals A sub 1 plus n minus 1 times d. Let's talk about the pieces here. This A sub 1 is my first term, okay? And d is my pattern. So I will either give you A sub 1, like I do in example 2, and the pattern, or my d, or I will give you a sequence and you have to find A sub 1 and you have to find your pattern, okay? So let's do it this way. So if we have my first term, for example 4 here, my first term is going to be 50. So I'm just going to plug this in. So I have A sub n equals 50. Man, why is this so off now? Okay, let's move this over some. So A sub n equals 50 plus n minus 1, and then it's times d. My d is my pattern, so I need to find that pattern. So to get from 50 to 44, I subtract 6. To get from 44 to 38, I subtract 6. 38 to 32, I subtract 6. So d is negative 6. So I'm going to put in a negative 6 for my pattern, okay? Okay, so now I need to just simplify this, make it a little bit cleaner, get rid of my parentheses. So negative 6 times n gives me a negative 6n. Negative 6 times negative 1 gives me a positive 6. I still have my 50. So I combine my like terms, I get negative 6n plus 56. So my rule is A sub n equals negative 6n plus 56. The rule that describes the pattern, or my explicit formula, is negative 6n plus 56. So the question could ask you just to write this and stop there. Or it could say also find A sub 20. All you're doing, substituting in that 20 where you see an n. So A sub 20 equals negative 6 times 20 plus 56. When you put that in your calculator, you should get negative 64. So A sub 20 equals negative 64. Okay? So you went from a sequence of numbers and you're able to write the rule for it and then use that rule to find a specific term later in the sequence that you were not given. Okay, so the other thing you could be using this formula for is to write the rule given A sub 1 and d, okay? So to keep my colors consistent, A sub 1, remember we did that in purple, and d we did in yellow on the previous example, so we'll keep it consistent. So I'm just writing my rule. So I have A sub n equals A sub 1, which is 46, plus n minus 1 times my d, which is 4. They just give it to me. I didn't have to find it this time. Okay. Now I just need to clean this up, clean up my rule, get rid of the parentheses so it's not so ugly. 4 times n gives me a 4n. 4 times negative 1 gives me a minus 4. And I still have my 46 out front. When I combine my like terms, you end up with 46 minus 4, which is 42. So you get 42, 4n plus 42. So a sub n equals 4n plus 42. So here it only asked for the rule, didn't ask for me to find any other term in the sequence. So I'm done at this point for this one. Okay? All right, we're going to skip the next two. Let's talk about arithmetic mean. Arithmetic mean, all it is a term for, arithmetic mean is the term for the terms in a sequence between two values or two numbers. So here this first one is asking how many arithmetic means are there between 10 and negative 18? Well, I go back to my sequence here. I have a 10 and a negative 18. So how many terms are there between them? There is one term, two terms, three terms. So there are three terms, three arithmetic means. Okay, so question you're more likely to be asked is to find the three arithmetic means between 8 and 14. All right, so what we need to think about is what is the difference between 8 and 14? And we need to divide that difference over the number of changes we have. So the difference is 8 minus 14 over the number of changes that we have. Well, this changes 4 times. Here to here is one change, here to here is a change, here to here is a change, and here to here is a change. To get from 8 to 14, I change 4 times. So I'm going to divide it by 4. Okay. So this equals 8 minus 14 is, divided by 4 is 1.5. So my pattern, this is really giving you your D. It's giving you your pattern. My pattern is between each space, I need to increase by 1.5. Each time I go up a term, I need to go up by 1.5. Okay? Once I know that, I can then fill in these spaces that I don't know. Okay? So 8 plus 1.5 gives me a 9.5. 9.5 plus 1.5 gives me an 11. 11 plus 1.5 gives me a 12.5. And just check ourselves to get from 12.5 to 14. It sure enough is 1.5. Okay? So that's how you would solve this one and find those what the missing spaces are. Gotta find your pattern first, then you can find the missing spaces. Okay, next one. Arithmetic. So those are all arithmetic sequences. Let's focus on series some more. So we talked about series back here in the beginning. In example 2, right here we talked about series, right? We talked about how when we're given a rule, we can plug that rule into our calculator and find the sum or the series of that rule. But if we're not given a rule, if we're just given a sequence, so down here, if I'm just given a sequence, I can still find my series. Either I can do it by hand, like right here, 2 plus 4 plus 6 plus 8 plus 10 gives me 30, if I add them up. Or there is a formula we can use for this as well, because while this is only 5 terms I'm adding up, what if it asked me to add up 1,000 terms? That would be a lot. So we have a formula, S sub n equals n over 2 times a sub 1 plus a sub n. All right, so let's talk about the pieces of this formula. N are my number of terms. A sub 1, guessing most of you would be able to guess this, is our first term because we've been using this for a little bit now. A sub n is my last term. Okay, so let's just prove that this formula works for this first arithmetic series. So I'm going to say, let's see, my number of terms is n. I have 1, 2, 3, 4, I have 5 terms. So this will be 5 divided by 2. Okay, to plug in for my n, I'm going to put 5 terms in there, times a sub 1 is my first term, so my first term is a 2. Okay, plus my last term, which is a 10. And I put that in my calculator. If you put that in your calculator, you will get 30. Okay? So you can either use the formula or you can do it by hand. Either way works. Okay. Now, this formula is the best method for finding an arithmetic series when you are given a sequence. Okay, when you're given a sequence, or you're given like the first and last term and the total number in that sequence, then this is pretty much the only way you can find it. Okay, you can find the series. Now, if we are given just the first term and the pattern, like we are in example 6 here, probably the best way to find this is to use my sigma like we did in the beginning of the lesson. Okay, so I'm going to use my sigma. I want to know for the first 6 terms, so from x equals 1 to x equals 6, I want to know what the arithmetic series is. But before I can do that, I first need to write the rule, because remember, to use this sigma, I need to have a rule I can put in those parentheses. So remember, on the last slide, we talked about how to write that rule. We use this formula up here, right? A sub n equals a sub 1 plus n minus 1 times d. So I need to first find that rule. So a sub n equals a sub 1 plus n minus 1, and it's times d. Okay. So I need to fill this in. A sub 1 is 4, so a sub n equals a sub 1, which is 4, plus n minus 1 times my d, which is 5. Okay? So then I need to distribute this 5 and clean up this rule so that I don't have parentheses. So 5 times n is going to give me 5n. 5 times negative 1 is going to give me a negative 5. Plus my 4. Combine my like terms. That gives me 5n minus 1 is my a sub n. Okay? So this rule I can now plug into my parentheses here. And then use my calculator to find the sum of this sequence. Okay, so I can go to my calculator. I go to math, and then I go to 0, and I just plug it in. X equals 1, and I want to go through the 6th term. And I put my rule in the parentheses of 5x. Well, remember, it's wherever I see n, I put an x. 5x minus 1. And I push enter. And then I get 99. Okay? So that's my answer. The sum of the first 6 terms in this arithmetic series is 99. Alright, if I forget all of this, I don't remember how to do it, I can also find this by hand. So I'm going to come down here and do this by hand real quick, just so you remember. I know my first term is a sub 1 is 4. Okay, so I'm going to start at 4. And then I'm going to add 5 every time. It says d is 5, so I know I'm adding 5. So, write this. So my first term is 4. My next term is going to add 5 to it, so that will get me to 9. So remember, this is my d right here, right? Then I'm going to add another 5 and get to 14. Add another 5 and gets me to, let's see, 14, 19, then 24, and then 29. Okay, so then I know I'm doing a series, so I need to add them all up. And if I add them all up, I get to 99. Okay, so you can get to the answer by hand. It just might take you longer. And it would be, if they wanted the first 30 numbers in this series, just write them out. If you forget the equation, add them all up. Takes time, but it will get you the answer you need. Okay? All right, so there's that one. And these two, again, these are just literally typing them in your calculator. So I'm not going to go over that. You can go back in the video if you want to watch that part again. Here, it's worded kind of funny, so let's talk about number 4. Find S sub 8 for the arithmetic series. Remember, whenever you see series, you should immediately think sum. I'm looking for a sum of numbers. With the nth term of a sub n equals 4n plus 3. So this is my rule. Okay? So to find this, if you want to do it with your calculator, is use your sigma, and we want to know from x equals 1 through 8, right? Because it tells me right here, f sub 8, I want to know the first 8. And the rule is 4n plus 3. Okay, so this went here, and this 8 went here. All right, and I just type in my calculator, and we'll just practice one more time. I go to math, 0, I want x from the first term through the 8th term of 4x plus 3, enter, equals 168. Okay. Again, if you forget how to do this, you can do it by hand. A sub 1 equals 4 times 1 plus 3. A sub 2 equals 4 times 2 plus 3. A sub 3 equals 4 times 3 plus 3. A sub 4 equals 4 times 4 plus 3, etc., all the way down to a sub 8. You'd have your a sub 5, your a sub 6, your a sub 7, your a sub 8. Okay, you would do it all the way down here. A sub 8 is 4 times 8 plus 3. Okay. Then you would solve all these out. You would get 7, 11, 15, 19, 23, 27, 31, 35. Okay, add them up, and you would get your series, which equals 168, right? I would add up all of these numbers, add them all up. If you add them, you should get 168. Okay, so you can do it either way, either using the formula or by hand. All right, so that's it for this video, and I will see you next class. Bye.